In this video, we will discuss few examples of NFA. Consider the language which consists of all the strings over alphabet A, B and they are ending in ABB. So all those strings should be accepted by NFA which ends in ABB. So the smallest possible string is ABB. So let us first derive NFA for that. Now string is ending in ABB, that means it can start with anything. So if we simply put arc of A and B here, we can produce all the possible combination of A and B, and then to end it we must have to read A double B, and then only we can go to the final state. So this is the desired NFA. Consider the case where we have to construct NFA for all the strings over alphabet A, B that has third symbol from right end is 0. So last symbol can be 0 or 1, second last symbol can be 0 or 1, and the third last symbol must be 0. So the NFA for that string would be this 0. Then we can read any symbol 0 or 1, and then we can again read any symbol 0 or 1. Now this will only create finite strings. Before this we can have any combination of 0 and 1. So if we simply put arc of A, B here, then we can produce all the possible strings in which third last symbol would be 0. Next, the NFA should accept all the strings over alphabet 0, 1 that contains 0110 or 1001. So 0110 and 1001 must appear in any string over alphabet 0, 1. So first we will construct the NFA which accepts only 0110. That is this, and if we add this, then it can also accept 1001. But this accepts only two strings, either 0110 or 1001. We have to produce all the strings which contains this. So before this we can have any combination of 01, and after reading these two same strings we can have any combination of 0 and 1. So this NFA will produce the desired language. Let us discuss few more example. Language L1 contains all the strings over alphabet A, B such that all string starts with A. So as shown from Q0, if we read A, then it is going to state Q1 which is final state, and from Q1 we can read any combination. That means we cannot have any transition for input B from state Q0 because string must start with A. L2 is equal to set of all the strings which contains A. So A, before A we can read anything, after A we can read anything. So from Q0 we can have an arc of A, B, then we must have to read at least one A to go to the Q1, and again after reading one A, that A we can have any combination of A and B, so we put arc on Q1. L3 is a language in which all strings ends with A. So as strings are ending with A, we are not allowed to read any other symbol once we read A and go to the final state. So before that we can have any combination of A and B. So we can put self loop on Q0. So these three are basic building NFAs of many languages. So try to understand carefully. Similarly, based on those three automata, the fourth one is L4 is equal to language which starts with AB. So all the string must start with AB, and at the end it can be any combination of A and B. So we just have to put self loop of AB on state Q2. So once we read A and B from state Q0, we are going to Q2. So all string would start with AB, that is ensured. Language contains AB. So all strings should contain AB. Before AB, that could be any combination of A and B, and after AB also there could be any combination of A and B. So we can simply put arc of A, B on initial and the final state. And L6 is all the strings which ends with AB. So once we read AB and go to the final state, we don't have to read anything. But before that we can read any combination of A and B. So this would be the finite automata or desired NFA. Construct the NFA in which accepts string of length 2 only. So our possible combinations of strings would be AA, AB, BA or BB. So for that, we can have a transition from set or state capital A to capital B on input A or input B, and similarly from B to C. So either we will be reading double A or AB or BA or double B. So all strings are of length 2. Strings of length at least 2. So string length should be 2 or more than 2. So we have to minimum we have to read double A, AB, BA or BB, and after that we can read any number of A and B. So we have to put self loop on state C. And language of strings of length at most 2. So NFA should accept strings of length 0, length 1, length 2, not more than 2. So initial state is the final state. So that will accept any string that will accept the string of length 0. Then on reading one symbol A or B, we are moving to another state capital B. So it is accepting strings of length 1. And when we move from B to C, it reads another symbol, and we'll be reading strings of length 2 in state C. So this is also very important to understand that how to put self loops and where to put final state when we are asked to construct NFA for fixed length of string, maybe a string of length n or string of length of at least n and string of length at most n. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.